Welcome to the next tutorial on electricity. In this tutorial, I'll be discussing the numerical problems on resistivity. I'll be discussing multiple numerical problems. For the first numerical problem, I will provide the solution immediately with this tutorial. For the remaining problems, I will read out in this tutorial and I will expect you to solve these problems on your own. Starting from next tutorial, I'll be discussing the solutions and you can compare your results with mine when I will discuss the solutions. So let me first show you how to solve the first problem, which is a wire of 10 meter long, 0.2 millimeter in diameter, has a resistance of 10 ohm. Calculate the resistivity of the material. So let us write the formula first. Resistance R equal to rho into L upon A, where rho is the resistivity, which we have to find out here. Length is given as 10 meter, which is already given in SI unit. Area is not given, but they have given the diameter, which is 0.2 millimeter. Therefore, radius equal to half of diameter, which is 0.1 millimeter. Therefore, area equal to pi into square of resistance. Pi means 22 upon 7. Resistance is resistance should be 0.1. Let me first work it out. There is a small mistake here. We have to convert the radius into SI unit. That means divide by 1000, because it is in millimeter. So divide by 1000 to convert into meter, which is 0.0001. So resistance is 0.0001 and resistance square will be square of that. And also they have given the resistance of the conductor, which is 10 ohm. So we need to find the rho, which is resistivity. So value of resistance is also given R, which is 10 ohm. Therefore, rho equal to R into A upon L. Now resistance is 10 ohm. Area is 22 upon 7 into 0.0001 square. And length is 10 meter. In fact, we don't need to write meter here. We do not need to write the unit. So 10 from the numerator and denominator cancels out. Therefore, resistivity rho equal to 22 upon 7 into 0.0001 square. So 0.0001 square is coming to be 10 to the power minus 8. So it is coming to be it is coming as 10 to the power minus 8, and 22 upon 7 is coming as 3.14. Therefore, the resistivity rho equal to let me write it in a fresh page, it will look better. So rho equal to 22 upon 7 multiplied by 10 to the power minus 8 ohm meter. 22 by 7 is 3.14. Therefore, resistivity of the material is 3.14 multiplied by 10 to the power minus 8 ohm meter. So this is the answer. So let me write it in the answer sheet. Therefore resistivity equal to 3.14 into 10 to the power minus 8. So this is the way we will write to the power with a hat sign, ohm meter. Okay, now I will be reading out remaining problems, and you can stop the video here and you can start solving on your own. Starting from next tutorial, when I will be discussing the solutions, you can compare your results with mine to find out whether your approach was correct or not. So let me read out the second problem, which is what will be the resistance of a metal wire of length 2 meter and area of cross section 1.55 multiplied by 10 to the power minus 6 meter square, given the resistivity of the material is 2.8 into 10 to the power minus 8 ohm meter. The third problem, calculate the resistance of a copper wire 1.0 kilometer long and 0.50 millimeter diameter. Resistivity of copper is 1.7 into 10 to the power minus 8 ohm meter. Okay, you can solve this. Let me read the next problem. Calculate the resistance of an aluminium cable of length 10 km and diameter 2 mm. Resistance of aluminium is 2.7 into 10 to the power minus 8 ohm meter. Okay, now you can solve, and let me read the next one. Calculate the area of cross section of a wire. If its length is 1 meter, its resistance is 23 ohm and the resistivity of the material of the wire is 1.84 into 10 to the power minus 6 ohm meter. So now again you can solve it on your own. Starting from next tutorial, I'll be discussing the solutions one by one, and you can compare your results with mine. So you can pause the video and start solving now.